Good afternoon, students. Am I audible?
Yes, sir.
Yeah. So we'll wait for 2 more minutes. I think others are yet to join. Wait for 2 more minutes. Keep revising the previous topics that we have discussed. Yeah. So we'll get started. Can someone tell me what was the last topic we were dealing? I remember doing this as the last problem, if I'm not wrong. Correct? This 9.9 was the last problem that we did, right? So
Yes,
means with this we have completed lens maker's formula, lens formula, and power of lens. So the topic that we are ready to start with is prism, right? So we'll get started with the next topic, that is prism. Okay. So let's write it down. So what does basically a prism mean? So prism is a refracting material without a doubt. A refracting material with at least, not at least, with both the, or I can say, yeah, both the refracting surfaces being planar in shape. Okay. So what I'm trying to say is, if I take a glass slab, right? So this side and this side are planar in nature. If I take this as the first refracting surface, this as the second, so they both are planar. If I take this as third and this as fourth, they both are planar. So if I ask you if this is a prism, the answer is yes, it's a prism. So what is the name of this prism? It is a rectangular prism, right? Similarly, if I take a shape like this, right, where I say this side and this side both are planar in nature. So this is the first refracting surface. This is the second refracting surface. Is this a prism? Again, the answer is yes. And what would be the name of this prism? It is called as triangular prism, right? So now our topic of discussion when we say prism, this is the triangular prism that we try to talk about, because the rectangular prism is given another name called as glass slab, right? Similarly, you have, when we say prism, we are trying to talk about a triangular prism. So let's get started with how this triangle prism responds to the light being refracted through it. Okay. So getting started with this, the concept is refraction through prism. Right. If I take a ray which is incident on the surface, okay. So at the point of incidence, what are we first supposed to do? At the point of incidence, we need to ensure that there is a normal that is drawn. Yes. So when the normal is drawn, you're going to define the angle of incidence. Then this ray is going to travel without any deviation. So this is said to be the actual path. Okay, having this in mind, let's try to understand one factor. So this is a rarer medium, this is a denser medium. So when light is traveling from rarer to denser, it starts bending towards the normal. So it starts bending towards the normal. So at the second point of incidence, what is going to happen is you're going to draw an other normal, right? This would have been the actual path. And when the ray is traveling from denser to rarer, it starts moving away from the normal. So this is R1, this is R2, and this whole thing is called as the angle of emergence. Okay, now listen to this carefully. So if I take this as A, B, and C, this angle A is called the angle of prism. So it is either called as the angle of prism or apex angle. Okay. Now, this is the incident ray. This is the refracted ray. And this is the emergent ray. Okay. Now, so let me take these points as D and E. So if I take the triangle DEF, if I take the triangle DEF, observe what is going to happen. D, E, and F. This angle is R1, this angle is R2. Then how much will this angle be? It is going to be 180 minus of R1 plus R2. Right. Now, if I take the quadrilateral ADFE, so if I take ADF and E, how much is angle F? It is 180 minus of R1 plus R2. Angle D in this case is going to be 90 degrees. Observe. Because you have taken this whole part. So this is the line which is a part of the prism and this is the normal. So I'll show you. This is the line which is part of the prism and this blue line is the normal. So the angle between the prism and the normal is going to be 90 degrees. So this is 90. Similarly, angle E is also 90. And this angle, if I take it as A, then what is going to be A plus angle D plus angle E plus angle F equal to? So since it's a quadrilateral, it is going to be 360 degrees. So what is angle A? It is A plus angle D is 90, angle E is 90, and angle F is 180 minus of R1 plus R2, which is summed up together as 360. So 180 plus 90 is 270 plus 90 is 360, 360 and 360 are gone. So A minus of R1 plus R2 is 0, which implies A is equal to R1 plus R2. So an important point to be noted here is the sum of the two refracting angles within the prism, the sum of the two refracting angles within the prism, that is R1 and R2, made at each side of the planar surface is equal to the angle of the prism. Okay, please make a note of this point. Write it down till this point. If there is any doubt, get it clarified.
So I have a doubt, sir.
Tell me.
So is there any specific name for angle R1 and R2, sir? Like what are they actually?
Sorry?
What are angle R1 and R2 actually, sir?
They are the angles made by the refracted rays at point D and E. So how many refractions are happening? See, this is one thing and this is one thing. There's the incident ray, normal,
Yes, sir.
angle of incidence. Now this is the actual path. The ray has got bent, right? The refracted ray, this refracted ray, whatever is the angle it is making with the normal at the first point of incidence is R1. Now this refracted ray will behave as the incident ray for the second planar surface. So at this point, if you draw normal, it will make another angle R2, which is going to be the other refracting angle. Right. So those two are the angles R1 and R2, where R1 is the angle made by the refracted ray at the first point of incidence, and angle R2 is the angle made by the same refracted ray at the second point of incidence. In both the scenarios, it is making an angle with respect to the normal. Did you understand what I meant?
Yes, sir. Understood.
Right. Now make it. You're done? Is everyone done writing it? So A is equal to R1 plus R2. So the two important formula that you're supposed to write here is angle F is equal to, 1 minute, angle F is equal to 180 minus of R1 plus R2, and angle A is equal to R1 plus R2. Okay. Now, there is something called as angle of deviation. So what is angle of deviation? So this is the actual ray. This is the refracted ray. And this is the emergent ray, right? Now see, this incident ray is traveling in the actual path. Observe what I did. This is the actual path and this is the emergent path. Means this actual path has taken a turn to come to this emergent path. So if you backtrace this emergent path, you're able to see the angle through which the incident ray had to bend to come out from the second refracting surface. Then this angle through which the bend has taken place is what is called as angle of deviation. Okay. So what is angle of deviation? Let's see the definition of it. It is the angle between the extended incident ray and emergent ray. Okay. Okay. Now observe. This point is D. This point is E. And let me call this point. So this is F. This is G. So if I take something like this, D, G, and E, if this is delta, and if this is R1, okay, if this is the angle of incidence, I want you guys to tell me what would this angle be? I'm sorry, 1 minute. Yeah. What would this angle be? It will be the same angle of incidence because they are vertically opposite angles, right? If this is the angle of emergence, then how much is this total angle? This is also E. Guys, are you able to understand what I'm trying to say?
Yes, sir.
Right. So then how much will this remaining angle going to be? How much is this angle? It's a very simple question that I asked. It is
I minus R1.
very good. It is I minus R1. In a similar way, how much is this remaining angle going to be? This is R2. So it will be E minus R2. Right. So what is delta? Delta is exterior angle. So can I say that exterior angle is equal to sum of opposite interior angles? When that is the case, I say delta is equal to I minus R1 plus E minus R2. So it will be I plus E minus of R1 plus R2. But just now we found out the fact that R1 plus R2 is A. So delta is equal to this thing. So from with this, we can conclude that delta is equal to the sum of the angle of incidence plus the angle of emergence minus the angle of the prism itself. This is another important formula that we are supposed to remember. Please make a note of it. There is any doubt, get it clarified. Yeah, done?
Yes.
1 second, sir.
Yeah, right. See, understand and write it, okay? Don't write it just for the sake of copying. If there is any doubt while you're copying, please ask me. Take your time, don't worry.
Done, sir.
Done? So moving on to the next concept. So now we understood how the angle of the prism is related to the the angles of refraction. Similarly, how the angle of deviation is related to the angle of incidence, angle of emergence, and the angle of incidence, right? So having these two formulas in mind, let's try to understand one thing. See, angle of deviation is something that is taking place inside the prism, right? So let's think of one fact logically, that out of all the angles that you're able to see, what are all the angles that is in your control? So what do you think are the angles that are in your control? Your control in the sense, when you do the experiment, yes, you can sure say that these are all the angles that I know even before I start the experiment. Think about it. Let me see who can guess it right.
Angle of prism.
That's right. So angle of prism is under our control because you can choose the prism that you want. You can either think of an isosceles prism like this, right? You can think of an equilateral prism. It is up to you, right? You can think of an isosceles prism also, where these two angles are same and you know this angle. So angle of prism is in your control. Similarly, there is another angle also which is in your control. This I've told many times. What is it?
The emergent rays, sir. Angle of emergence.
Angle of emergence is not in your control, right? Angle of emergence purely depends on how you give the this is output. How can you have the control over an output? So what are the input angles?
Angle of incidence.
Sorry? Angle of incidence. Remember, I've told this many times, even in the case of glass prism, even in the case of glass slab, when we try to derive the lateral displacement, you see the derivation would have been in terms of angle of incidence and the thickness of glass slab, because these are the two parameters which are in your control. In a similar way, here the angle of incidence and the angle of the prism are the two parameters which you can control. You can choose whatever you want, right? So knowing all these facts, it is not that this angle of deviation or all these things. We have tried to derive what would happen if this kind of a scenario takes place, right? Now, our important objective in real-time application is to understand how to find the, see, generally, if I give you a prism, right, that prism will be made up of some material. So what is the important property with respect to an optical material that is associated with it? What is the important property that is associated with it? I gave you the hint already. When you talk about an optical material, what is the important parameter or important attribute of that material about which you'll be concerned of?
The refractive index.
It's the refractive index. So we are doing all these things to understand if a prism is given in your hand and you're asked to calculate the refractive index of that material, how are you going to do it? Okay, that is what you do in the lab also in the name of experiment. So now we are going to get into the next step of this prism, and let's understand an important thing called as angle of minimum deviation. So before we proceed to the concept of deriving the refractive index of that material, it is important for us to understand the fact called as the angle of minimum deviation. So the name suggests something. There are two things that I suggested. So what is this delta? Delta is angle of fill in the blank. Deviation. Angle of that. It is angle of deviation. But delta M is the angle of minimum. There is a prefix added to the deviation called as minimum. So what do I mean by that? I need to have a clarity of what it means. Means observe. So angle of deviation depends on what all important parameters. Look at the mathematical expression. It depends on the angle of incidence. It depends on two input values and one output value. What are the two input values? Angle of incidence and the angle of prism. And it depends also on the angle of emergence. But who controls the angle of emergence? It is the angle of incidence. Correct? So having all these points in mind, so there are two things. One is like angle of emergence is controlled by the incident angle and the refractive index of the material also. Okay, so I have to clearly explain what this minimum deviation actually means. Listen to this carefully. Okay, now if I keep changing the angle of incidence, what will change in subsequent with it? If I keep angle of, see, for example, it is up to me, right? I told you angle of incidence is in my hand. If suppose I want to make a ray incident to the surface like this, then what is the angle of incidence I'm choosing? So I'm saying that the incident ray is grazing along this surface. What is it doing? It is grazing along the surface. Then what is the angle of incidence? Please answer this.
90 degrees, sir.
Yes, it is 90 degrees, right? So depending on this 90 degrees, the angle of prism is fixed because that material is going to have a constant angle of constant angle, right? But what is going to happen? The angle of emergence will change in accordance to it. Now from 90, if I make the angle 89 degrees, then you can observe that there is a change in the angle of emergence. If I change it to 88 degrees, then you can find a change in the angle of emergence. So like this, if you keep recording the data, means if you prepare a table like this, I, E, and you're preparing, so you already know the value of A, and you're preparing the value of delta. Okay. So I is 90 degrees. I don't know what is going to be here. Let's say it is 0 degrees. Then you're going to get certain value of delta. I'm just randomly writing. Okay. 89 degrees. Let's say here it is 1 degree or 2 degrees, whatever it is. Then delta. Like this, if I keep on writing, then if you observe this table, right, experimentally, there will be one particular scenario where this angle of deviation is there, right? It keeps decreasing and then it keeps increasing. And so what is happening? The angle of deviation is decreasing and then it is going to increase. So it will reach a minimum point here. So during that minimum point, what will happen is it is observed that the angle of incidence is exactly equal to the angle of emergence. Guys, did you understand the story? So what am I trying to say? If you control the angle of incidence, the angle of incidence is in turn going to control the angle of emergence. When these two are controlled, angle of deviation is controlled, correct? So if you keep making a note of that in a table, in a tabular column, okay, then one particular scenario will be where you can see that this value delta is there, right? That will be the least value among that lot. Okay, that least value is what is called as angle of minimum deviation. So in that least value scenario, what will happen? The angle of incidence will be equal to the angle of emergence. So if I have to represent it diagrammatically, if I take this as a prism, what is going to happen is the angle of incidence and angle of emergence will be the same, and this refracted ray is there, right? In this scenario, this refracted ray will be exactly parallel to the base. Okay, then this angle R1 and this angle R2 both will be R because it forms an isosceles triangle. Guys, are you able to understand this? Are you able to visualize? So this is the scenario. This is, sorry, any doubt?
Yes, sir, understood.
Understood? Okay, good. So this is what is going to happen when you talk about the minimum deviation condition, and this is the exact thing you are going to do in the lab. In the lab, if you have written your record book, you can open and check it. There will be a tabular column where they will ask you to write the angle of incidence. So angle of incidence is in your hand. You keep writing different values, and you will get one such scenarios where the refracted ray inside the prism is exactly parallel to the base, and that scenario, the angle of incidence will be equal to angle of emergence. Now, if you extend the incident ray and extend the emergent ray backwards, this angle that you're getting is what is called as delta with a suffix m. Sorry, subscript m. So delta m stands for the angle of minimum deviation. Clear, guys? Right. Now the whole game is going to be changed. See, delta is equal to, okay, delta is equal to I plus E minus A. This is known to us. And we also know the fact that A is equal to R1 plus R2. But at minimum deviation condition, what will happen? At minimum deviation condition, I will be equal to A and R1 will be equal to R2 will be equal to R. If I take these whole values and substitute it in both the equations, then what am I going to get? Delta M will be equal to I plus I minus A. Okay, which implies 2I will be equal to A plus delta M and I will be equal to A plus delta M divided by 2. Let me call this as equation number 1. Similarly, if I take this R1 is equal to R2 is equal to R and substitute it here, then A will be equal to 2R, which implies R is equal to A by 2. Let this be scenario number 2. Right. Now, what did I say? This condition of minimum deviation is going to help us to find the refractive index of the material. So, wherever refractive index and angles are involved, what is the immediate thing that should come to our mind? So what is the law that is going to relate the refractive index and the angles?
Snell's law.
So if you apply Snell's law at this boundary, then what is going to happen? Snell's law at any one of the boundaries. So if you apply Snell's law at any one of the boundaries, then 1 into sine I will be equal to mu into sine R. Accept it. Just check it. Outside medium is air. So refractive index is 1. 1 multiplied with sine of I will be equal to mu multiplied with sine of R. So which implies mu is equal to sine I divided by sine R. So sine of what is going to be the value of I? It is A plus delta M divided by 2 and sine of R is going to be A divided by 2. The refractive index of material in practical, that is in your lab, you can calculate it using this mathematical expression. Clear? So is the concept clear or not? Any doubt?
Yeah, clear, sir.
Clear, right? So please make a note of it. While copying, if there is any doubt, get it clarified. So let me know once you are done. Done with it?
Yes, sir.
So we will try out some problems which are based on this concept. Okay. So these are some problems based on prism. So there is a ray of light which is incident at 45 degrees on the face of an equilateral prism and passes symmetrically. Calculate the refractive index of the material. So what do you mean by passes symmetrically, guys? Can you guess? We discussed it just now.
Angle of incidence is equal to angle of emergence, sir.
So angle of incidence, perfect. That is right. So when they say it passes symmetrically means the refracted ray is there right inside. It is parallel to the base, or it is another way of saying that the incident ray is undergoing the minimum deviation condition. Okay, now the problem is very simple. What is the objective? You have a ray of light whose angle of incidence is 45 degrees. They told equilateral prism. So angle of the prism is 60 degrees. It passes symmetrically. So delta M is equal to how much? How will you find delta M? No need to find delta M actually. Oh, sorry, we need it, right? So delta M will be equal to how much?
I plus E minus A.
Think about it. 2I minus I plus E minus A. So 2I minus A. 90 minus 60. Why did they write 90? Because I is 45, E is also 45. So I plus E is 90 minus the angle of prism 60. So the angle of minimum deviation is 30. Now can you calculate the refractive index? Mu is equal to sine of A plus delta M divided by 2. So 60 plus 30 divided by 2 is 45 divided by sine of A by 2. That is going to be 30 degrees. So what is sine 45? 1 by root 2 and half is, sine 30 is half. The refractive index is going to be root 2. Guys, are you clear? It's a simple problem. I suggest everybody to write it down. Okay, make a note of the steps that I have written clearly. Right? Shall I move on? Yes or no, guys?
Yes, sir.
Yes, sir.
Right. Okay. Now I'll give you some time. You guys read it out. Try to draw the diagram for this. There is a ray of light which passes through an equilateral glass prism such that the angle of incidence is equal to angle of emergence. Again, it is a condition of minimum deviation. If the angle of emergence is 3 by 4 times the angle of prism, so angle of emergence is equal to 3 by 4 times the angle of prism, calculate the refractive index of the glass prism. So mu is equal to sine of A plus delta M divided by 2 divided by sine of A by 2. What is the value of A, guys? A is
60 degrees.
So angle of emergence is equal to 3 by 4th of 60. How much is it? 45. So delta M is how much? Seen? Delta M is going to be 30. So sine A by 2 is sine 45 divided by sine 30. It is exactly the same as the previous problem. Only thing is the question is asked in a different way. Are you able to understand? It's a simple problem. Right. Shall we try the third one? So there is a ray of light which is incident normally on one of the faces of prism of apex angle 30 degrees. There is a ray of light which is incident normally on one of the faces of prism of apex angle 30 degrees. So angle of prism is 30 degrees. Refractive index is √2. Find the angle of deviation. So how to find this? By the way, did you all see the sample, the question paper released by CBSE for term 2? Did you guys see it? Yeah, at least say an yes or no. Huh?
Yes, sir. I saw the pattern.
Pattern you saw, right? 12 questions were there. Right. It's actually simple only. Last time, no? For this thing, for term 1, you had almost 55, 45, yeah? Yeah, out of 55, you had to write 45. Compared to that 12, it is only 1/3. Not even 1/3, 1/4 almost. And you have 2 hours of time this time. Right? You can definitely do it well. And it is very easy, okay? Just work systematically, things are very simple.
So for this sum, should we substitute del m value in the del m formula in mu?
A ray of light is incident normally on one of the...
A plus del m, we can substitute del m value, right? So
no. You cannot use sine of A plus del m. Wait. Rohan, you're making a mistake here. How will you substitute A plus del m here? They didn't say angle of minimum deviation in the first place. Secondly, if you know the concept, right? You know the concept of angle of minimum deviation. When will it occur? When the angle of incidence is equal to the angle of emergence. You didn't read something important in this problem. What is it? A ray of light is incident normally on one of the faces of prism. What do we mean by normally?
Angle is equal to 90 degrees.
That is the mistake you are doing again. When a ray is incident normal to a surface, means the ray itself is acting like a normal. Then what is the angle of incidence?
0 degrees.
So if you look at the diagram, what they're trying to say is, okay, let me copy this. So it's a tricky question. Be careful, okay? So there is a ray which is incident normally on the surface, okay, on one of the surfaces. So when the ray is incident normal to the surface, what will be the angle of refraction? When the angle of incidence is 0 degrees, what will be the angle of refraction? That is also 0, right? It is going to hit the surface, right? Here the apex angle is going to be 30 degrees and the refractive index is √2. Find the angle of deviation in this case. So this is the actual path and this is the normal, right? The ray will bend away from it. So if I know the angle of deviation, emergence, then I'll be able to calculate the angle of deviation. Did you understand the diagram? Is there anyone having doubt? Right. Now listen to this carefully. This is not a problem based on minimum deviation condition. So R1 is equal to 0 degrees. And what about R2? I'm saying R2 is 30 degrees. Tell me how it is.
Because A equal to R1 plus R2.
So there is a relation, right? R1 plus R2 is equal to A. When R1 is 0, R2 will going to be exactly equal to A. So R2 is 30 degrees. Then R2 is 30 degrees. Refractive index of material is √2. Can I write √2 times sine R2 is equal to 1 times sine E? What did I apply? Snell's law. So √2 times sine of R2 is 30 degrees is equal to sine E. So √2 into 1/2 is equal to sine E. √2 into this thing is going to, so sine E is going to be 1/√2, 45 degrees. So angle of emergence 45 degrees. If this 30, listen to this carefully. If this is 30 degrees because they're vertically opposite angle. So out of 45, if 30 is gone, then how much is going to be the angle of deviation?
15 degrees.
This solve this problem. It is a very, very big problem. Okay. So you can expect these kind of problems in subjective tests. Right? Shall I move on? Shall I proceed to the next problem?
Yes,
Yes,
sir.
sir.
Yes, sir.
We'll do one last problem. Then there is one more concept that is left out in Prism, that is dispersion of light. We'll do that. With that, Prism concept is over. Fourth one. So try this. There is a ray of light which is incident on the face AB of a prism ABC, having the vertex angle equal to 40 degrees. The face AC is silvered and the ray of light is incident on the face AB such that it retraces its path. Okay, this is a slightly tricky problem. This I'll take, I need some time to explain this. This I will do it tomorrow. I want to complete this point. But if you want, I'll show you the diagram alone. You guys want to try it, you can try it today. But this answer, you need to use a logbook. Okay, listen. I'll draw the diagram alone. You can copy it. So it's a tricky one and it's a good one also. So there is a ray of light which is incident on the triangle ABC, having the vertex angle of 40 degrees. The face AC is silvered in the sense it is acting like a mirror, right? So a ray of light is incident on the face AB of a glass prism. So the angle of incidence is in such a way that the angle of refraction is there, right? The ray is going and hitting the surface on the other side. 1 minute. The ray is going and hitting the other side such that the light is incident on face AB such that it retraces its path. Such that it retraces its path. If the refractive index of the glass is 1.54, calculate the angle of incidence on face AB. I is equal to what? So that this ray is able to retrace its path. Okay. It's actually a simple problem only, but understanding is a tough part. So the question that we need to answer is, when will this light ray be able to retrace its path? So when will a light ray striking a mirror surface retrace its path? When the angle of incidence is how much? When the angle of incidence
90
is,
degrees.
again, same mistake.
It's 0, sir.
It should be 0. It should be 0 means the incident ray on the side AB should be in such a way that the refracted ray inside the prism is getting bent in such a way that it is going and hitting the mirror at an angle of 90 degrees, or the angle of incidence at that case is 0 degrees. So you're able to understand the difference. A ray incident normal to a surface means the angle of incidence is 0. Right? When this is going to happen, here what is the value of R2? What is the value of R2?
0.
That is right. It is 0 degrees. Then what is going to be the value of R1? It is going to be 40. Now, I 40 and 1.54. Apply Snell's law, you're going to get the answer, which is going to be this value. Right? Is the concept clear? This is also a good problem.
Yes.
We shall move on to the next part that is left out in this chapter, that is dispersion of light. Oh, I forgot to mention this as well. So during the condition of minimum deviation, what will happen is, this is also the thing that you'll plot in your exam, in your lab, sorry. If you take the angle of deviation versus the angle of incidence, means by controlling the angle of incidence, you are varying the angle of deviation. When you do this right, what will happen is, you can see that the angle of deviation will decrease and it will reach a minimum point for a certain angle of incidence, and again it will start increasing. So at this point where the minimum deviation is achieved, the angle of incidence will be equal to the angle of emergence, and there will be always two angles of incidence for which the angle of deviation is the same. So this is a graph that you're going to get. So if you ask me how this graph has come, it has come because of the experimental observation. Okay, when you do it in the lab, you'll understand things better. Right? Means once you plot this graph, from the minimum point, you need to drop a perpendicular onto the x-axis. So this point will be the point where the angle of incidence is equal to angle of emergence. From the same point, if you drop a perpendicular onto the y-axis, that will give you the angle of minimum deviation. Okay. So, hoping that this concept is clear, I'm moving on to the next part, that is dispersion by a prism. So this concept of dispersion is not new to you, right? You would have learned in your 10th grade. So when a white light is made to fall on a glass prism, what happens? When a white light is made to fall on a glass prism, what is going to happen?
Dispersion.
Dispersion means what? It is
Splitting of the light into different colors.
the splitting of white light into its constituent colors is what we call it as the concept is what we call it as dispersion. That phenomenon is what is called as dispersion, and this kind of the color combination is what is called as spectrum. So basically, this experiment says that white light consists of 7 different colors. When I say 7 different colors, it consists of 7 different wavelengths, which are combined together for us to see something called as a white light. Right? So when you talk about all these things, why this phenomenon is actually occurring is because of the concept of this wavelength. Right? So each wavelength will respond to this glass prism in a different way. That is the reason why this kind of a phenomenon is observed. So you're able to understand this? Right. Next is, there was another experiment that was performed by Newton, where the white light which is getting split is obtained back. So how is it done? If you take the white beam of light and pass it through a prism when it is kept upright, right, then it will get split into 7 different colors. When those 7 different colors are again passed into a subsequent prism which is kept in its inverted position, then all these colors will get combined to give you white light. Okay, so this is another experiment that was observed. Right, some natural phenomena due to sunlight is a simple concept which I'm leaving it to you to read, the rainbow concept and all other things. So generally questions are not asked based on this. It is only for your knowledge. So one is rainbow, the scattering of light, all these things, you can read it. So the last part that is left out of this chapter is optical instrument. Under optical instrument, we'll be seeing the simple microscope, compound microscope, and telescope. Let me check the syllabus once if I don't remember if telescope is there or not. So based on that, I'll be needing 2 more classes to complete. That is, by this week, we'll be done with this particular chapter. Okay. So in the meanwhile, keep revising. Is there any other doubt from today's class?
No, sir.
No doubt.
No doubts.
So I hope everybody made the notes. So Since there are no doubts, we can wind up, guys. I'll see you all tomorrow.
Thank you, sir.
Thank
Thank